Okay, when we're looking at the two different pizza situations, one without the delivery charge and one with the delivery charge, it's a good thing to sit at to look at them and go, all right, so how are they different? How are they the same? So let's look at this. How are these situations similar and how are they different? Well, they are similar in that, and I'll just type this in. Each pizza costs $7 in each situation, right? The cost of the pizza isn't that's no difference, but there is a difference as far as the delivery charge. And so one of those has a delivery fee and one doesn't, right? I guess I'll put a comma there. Boom. Now, when we looked at the table of data, how are the for these pizza problems? How are the tables of data the same? Well, if we go back up, and I'll try to go slowly so nobody gets sick, right? If you'll notice that this table here, the cost when you go from this number of pizzas to this to this to this, it's all plus 7, right? It increases by 7 every time. And if we go back even further to the first table that we had, to go from no pizzas to one pizza to two to three to four, it's still plus 7, plus 7, plus 7. So the cost increases $7 for each pizza. So let's go back down here and type that in. The cost increases $7 for each additional pizza, right? And how are they different? Well, one of them has a cost for 0 pizzas. Whoops. Hold on a second here. There we go. There we go. One table shows a cost for having 0 pizzas, which is just weird. Okay. Now, if we look at the algebraic rules, remember what an algebraic rule is? The y equals something else. That's our algebraic rule, including the y equals part should be included in every algebraic rule. How are they similar? So let's go back up and look. How are they? Here's one of them. Hold on a second. I'll highlight that baby. All right, here's one algebraic rule. Y equals 7x plus 5. And in this one, y equals 7x. So how are they similar? I would say that they each have a 7x. They each. Nope, don't need 2 eaches. All right. But how are they different? Well, one has that plus 5 going on, where the other one does not. Because remember, the other one was, we had the 2 algebraic rules. Y equals 7x. That was without the delivery charge. And then with the delivery charge was y equals 7x plus 5. Okay. And how about the graphs? How are the graphs of these two things similar? Let's look. Scroll up here, try to do it without getting you sick, right? So let's take a look at this graph, all right? It's a nice straight line. It's got a nice angle to it. All right, let's go up to the other graph. Take a look, take a look. Okay, nice straight line. Looks like it has the same amount of steepness too, I would say. Yeah, definitely has the same amount of steepness. So they are equally steep. So let's write in our answer here. Okay, so they are both linear. I love that word, linear, meaning they form a straight line. They have the same steepness. Uh-oh, I ran into the other grouping there. I'll have to move this up and shorten it. There we go. Lovely. They are both linear, meaning they form straight lines and have the same steepness. But how are they different? Well, let's go back up and look. How are they different? All right, we got this line. Passes through the y-axis at 5. And this one passes through the y-axis at 0 through the origin. Oh, well, so they are different in that one passes through the origin. And one doesn't. All right, because it passes through at 5 instead. Okay. Then let's go up here. What values make sense as inputs for the algebraic rules? So if we're looking at the algebraic rules for these two equations, right? This one and this one. What values for x would make sense? Would any negative numbers make sense? Can you order a negative number of pizzas? I don't think so. I don't think you can order a negative number of pizzas. So nothing in the negative. Thank you. There's nothing in the negative. And what about, let's see. So pizza without the delivery. Does 0 make sense? If you order 0 pizzas, you're going to pay 0 money. So that makes sense, right? So in this case, if we order 0 pizzas, the amount that you'll get charged makes sense. If you order 1 pizza, that makes sense. And 2 and 3 and so on, right? On up into infinity and beyond, as long as it's a whole number. But pizzas with the delivery charge, to order 0 pizzas and get charged $5, does that make sense? No, it doesn't. You can't have 0 pizzas, because if you do, you pay $5. But in this case, you have to order 1 pizza for the answer to make sense. Or you could order 2 or 3 or 4, or, on up until, any number of pizzas. But that with that delivery charge tacked on there, to order 0 pizzas and get charged $5, it just doesn't make sense. It just doesn't add up, Mr. Eaton. And you're absolutely right. Okay, so that takes us on to number 6. Now we're into the questions that you would normally be answering on your own, but we've got time, so let's take a look. Consider the following question. For which situation can you just multiply the input value by a constant, right? Just multiply the input by a constant number and get an output number. So to investigate this question, we're going to test a few input-output pairs. Start by thinking about the pizza situation without the delivery charge, okay? We're looking for the situation that has no delivery charge. So in the situation where you had no delivery charge, remember that was y equals 7x. When you double the number of pizzas that you order, what would happen to the cost of the order? Well, let's see. Let's start with a particular number. What if we ordered 2 pizzas? 7 times 2. Now that means that would give us what, 14? 7 times 2 pizza would be 14. Now, what if we doubled the number of pizzas? So instead of 2, we double that. So it'd be times 4, right? Because that's twice as many as 2. That's doubling it. How much would that cost? Well, 7 times 4 is 28. What happened to the cost of the order? Did the cost of the order double when we doubled the number of pizzas that were ordered? Looks like it to me. Should we try it again with another number to see if that's the case, or are we convinced that that is the case? Well, I got people leaving already. Y equals, I guess let's try 7 times 3. Whoops. Okay. So 7 times 3 is 21. What about y equals 7 times 6? Because that would be doubling it, doubling the order. 7 times 6 is 42. Is that double 21? It absolutely is. So when you double the number of pizzas you order, what happens to the cost of the order? Well, then the cost doubles also. Nice. What would happen if we tripled? So what I'm actually going to do is, for the rest of this assignment, number 6 and number 7, I'm going to leave you to answer those questions on your own in the assignment. So best of luck to you. We're almost out of time. I'm going to stop the recording.